pleasure to be here. I'd like to start off with a show of hands. How many people have seen in person a total solar eclipse? Good number of them. How many people didn't have to move anywhere to see a total solar eclipse? Anybody have the center line go right through their property? I knew I'd get down to zero. Okay, I'm going to start kind of in an unusual way. I'm going to read a quote from an old scientific journal article. It's from the memoirs, The American Academy of Arts and Sciences. This is volume 1, the initial volume, back in 1785. And the title of the article, Observations of a Solar Eclipse, October 27, 1780, taken from the east side of Long Island in Penobscot Bay. What's interesting, 1780, Revolutionary War, and the British were in charge of Penobscot Bay. And these guys had to ask permission from the British to go in there, set up shop over a week's time, and then observe an eclipse. And they got permission. There's nothing like a war when it's compared to a solar eclipse. Okay, a total eclipse of the sun is a curious and uncommon phenomenon. From the principles of astronomy, it is certain that a central eclipse will happen in some part of the Earth in the course of every year. But it is but seldom that a total eclipse of the sun is seen in any particular place. What is this curious and uncommon phenomenon? Well, basically, it's seen from some locations on the Earth. The moon moves in front of the sun and blocks it out. It becomes dark. Stars come out. You can see planets. And there are all kinds of phases that happen during the eclipse. I'll explain these, show pictures of them, and explain how and what causes them. You've probably seen a lot of publicity. It ain't going to quit, not until the solar eclipse comes. People travel long distances, the other side of the world sometimes, and then hike into a remote spot just to observe eclipses. They have t-shirts, eclipse chasers. And the cruise boats, they offer eclipse cruises where they actually put the boat in the path of totality out in the ocean. And sure enough, they've got some astro nerd aboard telling them what they should be looking at. And he'll give a talk something like this. I'll give a website, and then of course no talk is ever good without a diagram, so I've got one. How uncommon is this? And where is the center line going? What there is to see, bit of literature about it, how to observe it safely, selecting a viewing site, photographing an eclipse, weather, and then finally a couple tales about eclipses. This is a long list. Don't worry, it's not... Oh. That was my last class. There's so many topics that they'll change topics very quickly, so if you don't like what I'm talking about, hold on, we'll do something different. Finally, before I start, if you want copies of this talk slides, after the talk, I'll have a place to sign up. I would need an email or a phone number, or actually, Ruthie will have a copy of the slides also, and you can get them from her.
Wow.
So either or contact me. Also at the end, I'll have a handout. This is a handout with a bunch of information that now looks like gobbledygook. Maybe by the time I'm done talking, it'll make a little bit of sense. Way up in the corner is, again, my email and phone number. And then the thing says, Google Mr. Eclipse. So that's what you start off the talk with. You Google Mr. Eclipse, you get him. There he is. That's Fred Espenak. He used to work at Goddard Space Flight Center. He's retired now. but he's got another guy helping him. He spent most of his career developing this website on the internet. One thing to remember, people all around the world look at this website. So the times are not Eastern Daylight Time. They'll be Greenwich Time. Okay? Mostly, and that's called UT or GMT. In order to get Eastern Time, you have to subtract 4 hours. And this is true with most websites or anything you see publicity that's global in nature. If you forget to do that, you come out at 6:30 to see the eclipse, and you're 4 hours late. If you Google it, okay, there's solar eclipses for beginners, and you get this, and you get that, and there's a whole list of eclipses over the last 6 years. The middle there is August 21, 2017. You can click on that. You'll get more information than you ever want to know. If you go down further, notice there's a 6 and a 10 millennium catalog of eclipses. 10,000 years worth of eclipses on this website. This guy has done a lot of work. And there's a lot of photographs. So you can find all kinds of photographs of solar eclipses. No, this is not going to work. Okay. Also, they put out a book. This book, August 21st, 2017, this book is just for this one eclipse. He puts out a new book for every eclipse. And the one on the right is now they have a color edition. Okay, I promised you a diagram. Here's a bunch of things that nobody can figure out. I try to get a simple one, and it looks like this. Now remember, this is in 3D. So sun, of course, is like a ball, and so is the moon. And the little dark shadow here is like an ice cream cone. That's called the umbra. Somebody in the umbra cannot see the sun. The moon is too big and it's in front of the sun. Guy in there is seeing only the backside of the moon, the unlit side. He is in total eclipse. Now, if you get far enough away, you can get down into the antumbra. If you're that far away, the moon looks smaller than the sun, and even if you're lined up, you don't get the sun all covered up. You get what's called an annular eclipse. You can see the sun outside the moon, because the moon is smaller looking than the sun in the sky. Then finally, if you're in the penumbra, a guy there can see part of the sun and the backside of the moon, so he sees a partial eclipse. Now these three phases, I'll illustrate them now right here. If the Earth goes by like that, the guy sees, first of all, partial eclipse, and then as it goes by, people in the very right position will see an annular eclipse, and then they go by in partial eclipse again. What we're having in August is this, where it goes through partial eclipse, total eclipse, and then partial eclipse again. And that doesn't, it's a lot of words and stuff. All it means is the sun's sitting there and the moon kind of moves by. And right in the center, for a couple minutes, it'll be covering up the sun completely. And then it'll move past. And the sun will reemerge from behind the moon. How uncommon is it? Here's 25 years of total eclipses around the world. Map of the world. If you look at Europe, they get no eclipses from 2000 to 2025. Continental Asia, 3. Africa, 3. South America, 3, and a little bit of a 4th. North America, 3. Very uncommon. If you're on the green in a random spot, what are the chances of you being under one of those blue stripes? Not very much. Okay, I'm going to zoom in. There's 2008. That eclipse, of course, occurred 9 years ago and just barely touched Canada. 2017 is what we're seeing this month. And then 7 years from now, there'll be another eclipse that goes up and across the United States also. Now look at, they cross each other right there, and that's southern Illinois, and that's Carbondale is one of the towns in there. The people at Carbondale are trying to rename their town Eclipse Town, USA. I'm going to concentrate now on North America and add another 25 years. In North America, total eclipses, 50 years worth. There are the three we saw already. 2008, way up top. 2017 going this way, 2024 going that way. 2033, one in Alaska, one in Canada, and 2045, another one across the United States. But even in 50 years, chances of living in a zone of totality is very small. We nailed it on the head right here. Couldn't have been closer. I'm going to track the whole eclipse across the earth. And what you can think of this is a shadow of the moon moving across the face of the earth. And if the shadow goes across you, you're in total eclipse. So it starts out in the Pacific Ocean. And they see it right after sunrise. It hits Oregon on the west coast in the morning. It'll hit here in the afternoon, and in the Atlantic, people will see it just before sunset. Here's the track going across the United States. Again, that looks like the shadow of the moon. The blue is the outside, and the red is the center line. So I'll track it and show it very quickly because you might have a friend in Oregon or western Nebraska or somewhere. You might want to see if he's going to see the eclipse. I have a son in Portland. They're north of the eclipse. He's got to go south. He told me motel rooms are $1,000 a night. He's not going south. He's going to watch it on TV, I think. But Salem, Oregon is there, and then across Idaho, Jackson, Wyoming. Actually, center line goes through the airport. Down through Wyoming near Casper, into western Nebraska, goes south of Lincoln and Omaha. Nebraska going into Missouri. Kansas City is barely in there. So is St. Louis on the northern end. Comes through Kentucky, a little bit of, Tennessee, a little bit of North Carolina, and then comes into Oconee County. South Carolina, goes near Columbia, and then out into the Atlantic north of Charleston. Charleston is inside the zone. And I know you're all looking right up there, trying to focus in. That's where we are. My next slide will show that red rectangle. And notice that everybody inside that rectangle is well within the path of totality. Everybody in this next slide will see total eclipse. There's Lake Kiowee. Maybe you can recognize Route 123, Seneca, Clemson, Ollie, the Lifelong Living Institute. There's Walmart. The eclipse cuts them right in half. There's Waterford Point. I have neighbors there. Clemson Downs. You are very close to the center line of the eclipse. Less than, about a mile, it looks like. Yeah. Here's the Lighthouse Restaurant. And the cove below it. And here is part of Waterford Point. And I'm going to blow it up because I know these people. And I know Doug and Lynn Carlson, and the center line is going right through their backyard. And the Sweeneys and bowling and so forth. Here's an interesting thing. That line I plotted a couple months ago. I had done the same thing about a year or so ago and got that line. And the reason was it's impossible to know exactly where the Earth is going to be in the future, the rotation of the Earth. And the rotation of the Earth was now more accurately predicted because we're closer to the eclipse. So the red line is the more accurate one. The yellow one was from a year and a half ago. Uncertainty of the Earth's rotation. And then it goes down the cove, it goes through these guys. Whipperman's Dock, there it looks like it's going to get cut off. Here's an important point. This is the shadow of the moon going across the United States. Notice Seneca and Clemson, S and C, they're right near the center line. About a third of the way out is Easley, then Greenville, then Greer. If you're in Seneca or Clemson, the eclipse will last 2 minutes and 37 seconds. If you're in Easley, 2 minutes and 27 seconds. Not much difference. You won't know the difference. 2.5 minutes both ways. Even if you're as far away as Greenville, off the center line, you still get 2 minutes of totality.
Wow.
Yeah, it's only if you're very near the edge that you significantly lose this time. So the point is, you don't have to be on the center line. Doug and Lynn Carlson were very happy to hear that. Because they were sure, now they're happy, see, they're smiling. They were sure their backyard was going to look something like this. Incidentally, that's from Woodstock. No, not going to happen. And these are the Whippermans with the dock there. They were sure that this was going to happen. Not going to happen. Okay, what to see during the eclipse? A number of things happen. First of all, the partial eclipse, as I explained, the moon starts moving across the sun. It takes about an hour to do that before it gets to a point where it's going to cover up the sun. Somewhere along the way, there's something called Bailey's beads. I'll explain them more in a minute. What had happened is all of a sudden the very thin crescent, before the moon completely covers the sun, that crescent, little sliver of light, will break up into blobs of light and gaps of darkness. It's a very quick phenomenon. It lasts only a couple seconds, but it can be spectacular. Just before totality, reddish profile, and then totality. And for this eclipse, it'll be 2.5 minutes, 2:37 if you're right on the center line here in South Carolina. It is possible for an eclipse to last over 7 minutes if the orbital positions are optimum. Somewhere in the middle, there's something called a diamond ring, where you see a bright thing of light and the solar atmosphere around looks like a diamond ring. Now, I'm not a real eclipse expert, so I went on the internet to try to find out what causes it. And 50% of the websites say it's just when the last little bit of that crescent sun disappears, there's just a little bit left, and then the atmosphere of the sun, that's what causes it. Other websites say, oh no, it's the last Bailey's bead before complete totality. So I couldn't figure out which one was right. I wrote to Mr. Eclipse. I've dealt with him before, and he wrote back and he said he thinks number one is the correct reason for the diamond ring. But I'm thinking, gosh, one of them happens before Bailey's beads, the other happens after Bailey's beads. How hard is it to tell which one comes first? But I don't know. Then, of course, after totality, the moon moves away, and these same things happen in reverse order. I'll show that in a second. But here's another point to remember. Long partial phase, then all of this stuff I just showed, and then a long partial phase again. Each of these lasts about an hour. This whole thing, including totality, is 4 minutes. Less than 4 minutes, actually. So you've got 4 minutes of action and an hour on each side of being in the hot August sun.
Is it safe to watch all of them with it?
All right, I'll get to it. Good question. Good question. I'll get to it in a few minutes. Bailey's beads and solar prominence. A guy named Bailey was the first to even explain what Bailey's beads were. He was 6 years old at the time of that Revolutionary War eclipse. That author actually drew Bailey's beads, but didn't know what they were from. Okay, you look at the moon, nice and smooth, huh? Nice, perfect circle? No. Here is an exaggerated profile of the moon. It has mountains and valleys. If you look at the edge very carefully, this, of course, again, is exaggerated. But I think you can picture the last sliver of the sun disappearing behind the moon. Just before it's all gone, some of that sliver will be shining through the valleys, and other parts of it will be obscured by the mountain. So you will see kind of bits of sunlight and gaps of darkness. It's called Bailey's bead. It lasts only a couple seconds. Here are a few pictures of it. I won't spend too much time on it. Again, that kind of lasts less than half a minute, that part. The diamond ring, there are two different definitions. Reddish profile. Maybe you see a solar prominence. You may know that the sun is a very active place. And if you look at the disk of the sun, you'll see sunspots. If you look at the edge, you might be able to see a solar prominence. Big eruptions of stuff coming out of the sun. And then totality. You see the solar corona. And the sun has a magnetic field, and when it shoots out particles, they follow the electric magnetic lines. So you can see kind of structure, and each one is different. Sometimes the eclipse doesn't show very much structure at all. In totality itself. They say it gets creepy dark and cool. Temperature drops quickly. Stars come out. Crickets start chirping. Dew settles. Nocturnal animals emerge. Of course, these last couple of things are very much more likely in a 7-minute eclipse than one that lasts only 2.5 minutes. But you'll get the idea, that's for sure. And the distant horizon glows orange. No, not because of Clemson. A few more pictures of the solar corona. After totality, and totality is 2.5 minutes, dark sky, stars are showing, planets are showing, corona, prominences, and then the reverse order. Maybe a reddish profile. Diamond ring number 2 now be the first Bailey's bead to reappear. Bailey's beads, diamond ring definition number 1 maybe, the appearing cusps in the solar atmosphere, and then the partial eclipse for the final hour. Now notice, I sometimes show that for the reddish profile, and sometimes this one with a prominence. Some of the coronas are pretty, and some of them aren't. It happens that the sun has an 11-year cycle, during which a number of things get stronger and weaker, like the magnetic field, or more frequent, like the prominences, or less frequent, or the sunspots, you get more of them or fewer of them. And actually, every 11 years, the whole magnetic field switches on the sun. So if you have a compass that shows north, 11 years later, it'll be pointing the opposite direction. That actually happens on the Earth, but it takes thousands of years to switch. If the sun switches every 11 years from north to south and then south to north, so some people refer to a 22-year period. It's just because a full north to south to north thing. But the prominences, the sunspots, magnetic field, their frequency and strength do go through maxima and minima, and then a maximum and then a minimum. Unfortunately for this eclipse, we're pretty close to the minimum. So it means that we don't have as good a chance of seeing a prominence or very extended structure for the corona. But we will see 4 planets. If you look now, this represents the west and the east, so the sun comes up in the east, goes up and then down. Jupiter will be over in the east, as if it had just risen a couple hours ago or so. Venus will be in the west. It will set before the sun does. Both of those will be brighter than any star. Mars will be visible near the sun. It's reddish, so you can see that probably. Venus will be to the left and down a ways, Mercury, and that will be hard to see. Mercury is quite faint, and it might be in the solar corona, so you might not see it. And then the star Regulus will be fairly close to the sun. You can see all of these things. And again, I remind you, an hour on each side, 4 minutes in the middle. Here's an interesting thing. The duration is 2 minutes and 37 seconds. And here it starts at 2:37 p.m. So you only have to remember 3 digits instead of 6. And of course, that's 6:37 UT, or Greenwich time, or 1837. Okay, solar eclipses in the literature. Mark Twain, Connecticut Yankee in King Arthur's court. This Connecticut Yankee was going to be executed, but he knew there was an eclipse starting. So he threatened the king. He sent a message that he will blot out the sun if he's executed. Then the eclipse starts. So the king, name any terms, Reverend Sir, even to the having of my kingdom, but banish this calamity. Spare the sun. That my fortune was made. And Bob Newhart, similarly, I love this guy. 7 lost cities of the Incas. Our arrival happened to coincide with an eclipse of the sun. And so the natives thought we were some sort of gods. They begged us to return their sun to the sky, which, of course, we did. Okay, one thing of science. Einstein came out with his theory of relativity in the early 1900s, and it wasn't believed because it had some crazy stuff. Time isn't the same, and distance and all this stuff. One of the major tests that he predicted is possible and can be measured only during a solar eclipse. The fact that starlight is bent by a heavy gravitational force. So starlight coming by the sun gets bent. So if you're here, and the sun is here, and you're looking at a star, it looks like it's that direction. But actually, if you trace the star backward, the light ray backward, it's curved. It's come this way and then around, so it looks like it's coming from here, but it's actually coming from over there. So what the deal is, the little circles are where the star actually is, and the filled-in circles are what it appears to come from. So they measure the thing a number of days before, or at night, 6 months before, whenever, measure those stars, and then they wait for the eclipse, and when the eclipse happens, they measure the stars again and see if they have all kind of appear to be closer to the sun. Now, one thing, this is a very, very accurate type measurement. The effect is nowhere like what's exaggerated on this slide. The effect at most is 1,000th the diameter of the sun. So it wasn't actually measured until 1919 by Eddington. And he got what Einstein's theory predicted. And this was one of the great confidence builders in relativity. There were two others, gravitational redshift and orbital changes of the planets. Mercury was behaving in a way that was unexplained, and guys were trying to put planets inside Mercury and say, this planet will affect Mercury. But no, Einstein came along and he said that unexplained part is shown by my theory of relativity. So relativity became accepted in the scientific community. Okay, here's a warning. When viewing the eclipse, in the partial phase, when any part of the sun is uncovered, you should be using the glasses. Never look through sunglasses, welder's glass, photographic negatives, do-it-your-own scopes, or your naked eye, of course. Eye damage can be permanent, even when not painful. You go on to Mr. Eclipse, he's got about 5 pages worth of MDs, warnings, and so forth, and what happens, and etc. Welder's glass number 14 and higher numbers are okay, but not many people have welder's glass. We do have glasses, and Ruthie mentioned that. To watch the thing happen through these glasses. There are things called solar viewers, but I don't really see the sense in those because you have to hold them. You put the glasses on and your hands are free. And to purchase, okay, you can get them online or whatever. The handout has information there. You can do other things. Here's a pinhole camera. And you can make a little hole in a sheet of paper and then let it go through. It'll show the sun on the far page. But this is an exaggeration. This is very deceptive because we know the angle of the sun, what angle it extends, and it should extend only 1/100th of L. So the diameter of the object should really look like that, not what's drawn here. But you can do other things. There's a paper plate, and the guy's got a thing there, and it's possible to figure out just about that he has the pinhole about 5 feet away to get an image that looks like that. And then you see the sun, it's a crescent shape. Punch a pattern of pinholes in a thin sheet. You can do this. Solar eclipse, 2009, July 22nd. This was in Japan, the guys from the NAO, the National Astronomical Observatory. Interesting, the dot on the eye in eclipses is brighter than the other ones. The hole's bigger, but if you look carefully, you'll see that it's not as in good a focus. So to make the hole bigger, the focus and resolution kind of deteriorates. Make it smaller and you don't get as much light, but it's sharper image. There's 2 holes and 2 illustrated. Kitchen colander. Ritz cracker. And don't forget the white surface to shine the patterns on. Here's an Australian guy. He's lucky he had some white paper with him. If he didn't, where would he shine at? On the ground, it wouldn't show. And if you're actually in a leafy forest, when the sun comes through some of the leaves and hits the ground, it'll make patterns just like that. So there's the crescent sun, and these things will be a number of inches wide because the holes are kind of high up in the air. And you can make a box like this. Put a white piece of paper on one edge, little thin paper to make a pinhole with. Make it high up in the box so it's over your head. But again, it's much exaggerated. The image will be very small, so you're better off making a whole pattern and looking at that. Here's one I made. And I can slide stuff in and out so I can slide in different patterns. And you can put binoculars on a tripod. Anybody know why this is very dangerous? Two reasons. First of all, you can start a fire with a pair of binoculars if you put something burnable right near the thing. But secondly, if you leave that sitting there, somebody's going to come along and look through it. He'll blind himself. So you start fooling around with cameras and binoculars and stuff, be very careful. This is serious. Okay, I tried it and I didn't really get good results, so if anybody gets, wants to look at my slides later, it'll show you how to do it, but you can see me afterwards. You can put actually a filter in front of a pair of binoculars. Make sure it's on the front end before the light goes in. Make sure it's secure. You don't want it to fall off while you're viewing. And no unfiltered sunlight. Make sure it's completely covered. No holes in it. Put your binoculars to your eyes and then find the sun. And then look away and take them off. Okay. That's just kind of crude, but it works pretty well. I took a pair of the glasses and cut them and put them in front of the binocular lens. How about that? No. You've got to put the stuff in front of the binoculars, not behind. And this thing, if you look at the sun like that, it'll burn a hole in the glasses and then in your eye. It's dangerous. So do it like that. Remember. Okay. Make sure you have adequate protection. Yes. Yes. No. Look at these ladies. Anybody recognize anybody? Anybody know what they're doing wrong? Hold it. Sunglasses do not work. Gotta put on the real thing. Okay, choosing a viewing site. You got two considerations. First of all, you got to see the sun, so you have to have a good view of it. But you want shade nearby. This is middle of August. It's not going to be real cool out there. You don't want to wait through an hour of partial eclipse to see 4 minutes of stuff. People ask me, how about a boat? Yeah, I think okay, with a couple reservations. First, you can't put a tripod on there, because it'll be herky-jerky all over the place. And secondly, I got a feeling that the lakes around here are going to start looking like, kind of like that. There'll be crazy people going full speed with a crowded lake, and they'll chop, and the water will be bouncing around. Okay, where in the sky will the sun and moon be? Where will it be when it takes place? Behind a tree, behind a house? If you're looking for a site to view, go out now or in the next couple of weeks and look to see where the sun is around 2:30 in the afternoon. During the eclipse, it will be a little bit lower and a little bit toward the south, okay, than it is now. But you'll get the general idea, and if it's visible, it'll be visible in 2 or 3 weeks. And don't forget your personal comfort. You're going to make sure you have shade, make sure you have enough water to drink, enough things to drink, and when those precious 4 minutes are approaching, you don't want to be panicked. It happens once. You don't get a second chance at the eclipse. Can't put it on pause or anything like this. And would-be photographers, I've spoken to a couple photography clubs, so I won't spend a lot of time with this because I'm kind of negative. I don't advise people to go try to take pictures, not of the eclipse, for a number of reasons. First of all, your camera has to be treated like your eye. Some of these cameras are very sensitive, light meter stuff that adjusts exposure. If you put the sun on it long enough, you could damage your camera. So in the partial phase, when any part is uncovered, the camera should have a filter on it. And it should be on the outside of the camera before the sunlight gets to the camera. So you can take the camera with a lens, cut a piece of the glasses off and stick it on the end of the lens. 3 points to be made. Sun and moon are very small in the sky. So go out with your best telescopic lens, see what the results look like. I did that with my little camera, and that's the moon at night. I didn't bother with the focus or anything. I just want to see what size it was. I've got a 20-factor zoom. Most cameras have only 5. You have a 5 factor, the sun or moon will look like that. It's not worth doing. 2, happens very fast. I've mentioned that before. This whole action is less than half a minute. You can't photograph all the phases. You fool with a camera and changing settings and filters and blah, 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 and maybe dark. You miss the eclipse. I know guys who said they've been to eclipses. They haven't seen one. And they're here for, oh, darn. Number 3, the internet is full of great photos. I just Googled solar eclipse and I got that. These are professional ones. These guys are taken by observatories that happen to be in the path of the eclipse. That's how you get photographs like that. Here's a beauty. But you can figure out, knowing the diameter of the sun, which we do, and the height of the kid, which is about 5 feet, you can figure out how far away he was. 1,700 feet, a third of a mile away, to get the kids as small as 1/3 the size of the sun. And he's halfway across the lake. Anybody have a camera that can get that kind of resolution, third of a mile away? So my wife thinks that that's Photoshop, and she may be right. Superimpose stuff. Here's an actual photograph, real structured solar corona. This is done by a professional, this guy Mueller from the Czech Republic. He talks about it. Solar eclipse photography is one of the most difficult tasks of astronomical photography. Extreme contrast, it's impossible to record at all on a single image. No chance to experiment. Well, I take it back, there is a chance. 7 years from now in Carbondale, you can go in. And the image processing, he did not use Photoshop. He's got very sophisticated software. Here's another phony one. You think it took a picture every 12 minutes or so going down, but look at the ocean. That's a single picture because there's one wave breaking. If he took a picture every 12 minutes, it would be just a blur. So that's Photoshop. Superimposed images, yes for the sun, or maybe for the sun, no for the ocean. Okay, so photograph the eclipse. I say enjoy the eclipse. Partial phase, thin crescent, diamond ring, Bailey's beads, totality, reemergence. A few photos during totality, maybe plenty during the partial eclipse. There you have a little bit of time to mess around with stuff. Why not photograph your friends with their pinhole boxes? I mean, look at these guys. How about him? And of course, there are always some that don't think they have to obey the rules. There are some here at Clemson Downs. Their pictures are on the wall in the post office. These guys, look at this. No, they're not protecting their eyes. We've got to get the glasses on the people. And there's one over there who thinks you can wear sunglasses. Wrong. Put the glasses on. Uh-oh. Maggie really wanted. her mother here. And there's Libby Allen. But we have to patrol this stuff. Get the glasses on him and look at the top. He's got sunglasses again. Got to change them. Okay. All right. Long before the eclipse, if you're going to do anything with the camera, go out there and shoot the sun with a number of different exposures with the filter in front of the camera. See how they come out. It's the same almost all the way through the partial phase. Use the same setting. Only at the very end you have to start opening up. And then if it's hazy for the eclipse, you have to do it also. Mr. Eclipse tells you all this kind of stuff. But once again, 4 minutes, you don't get a second chance. So thoughts. Don't try to do too much. If you're going to get some photos, know what you're going to do and practice beforehand. Photo checklist, make sure your flash is off. During totality, if you flash, people will kill you. Make sure your battery's charged, make sure memory card is not full, and make sure your camera doesn't have this delay. You know, sometimes you hit the button and it starts fiddling around with red eye and focusing and all that. By the time they click, the thing you're trying to photograph will be gone. Daily speeds last only a couple seconds. You want that shutter to flash right when you hit the trigger. Okay. When can I take the glasses off? Well, one rule is when you can't see anything through them. If you're looking at the sun, you'll see the sun, and you might see Bailey's beads, but then you'll see nothing. Take them off. It only is when the sun is uncovered. So here's kind of the key. Right when Bailey's beads forms and starts to disappear, you can take them off. So as the hour goes, keep them on. Bailey's beads, you take them off. Totality. And then reverse when it goes the other way. As soon as Bailey's beads appear, put the glasses on. Okay. Finally, we hate to talk about weather, but we got it. If it's fully overcast, there's nothing much you can do. You can go inside and watch it on TV. Now, I used to tell people if it's partly cloudy, get a good weather map, radar map, to see where the weather is going, and try to get in your car and go where the weather is going to be better. And if you know all the routes and stuff, stay on them. You don't have to be on the center line. You can be anywhere in the path. But now I'm not so sure. NASA has estimated that the state of South Carolina could see an influx up to 1 million people to witness this eclipse. What does that mean? And besides that, they're going to want to be near the center line. You don't know that you can be kind of out toward the edge even and see plenty of good stuff. So you're going to squeeze 1 million people into there. It's going to look like that. So you don't want to have to view the eclipse from a parking lot. There's Joe's Pizza next to Ollie. All the restaurants are going to be full if this prediction is correct. And here's the grocery stores. I really have no experience in this, and I don't know what to tell you, other than this is a possibility. We have friends coming to visit us, and I'm telling them to get here a couple days early. I think the I-85 can be just bumper to bumper.
The hotels are completely booked. Yes,
Hotels are
all
booked.
guest
I bet they
houses.
may kill them.
Yeah, they will, but they are. They're all booked, so they're already booking like in other states.
Last thing, in weather, here's a map of the U.S., and you can see the line. And what I hate to tell you, bluer it is, a better chance of good weather. So Oregon and Idaho, that's where all the professionals are going. Get down to South Carolina, and it's pretty not as good a chance of good weather. So all we can do is just sit here with our fingers crossed. Okay, I'm going to finish with two quick tales. July 20th, 1963, there was an eclipse in Maine, went right through the university and down to Bar Harbor. It was a partly cloudy day, and guys were in their cars going up and down the back roads of Maine, chasing holes in the clouds, hoping to get to a place where they could see the sun through the clouds. One guy, near the time of totality, found a great hole in the clouds, pulled over to the side of the road just as it started getting dark. Along came a car, driving by, and what did the driver do? Here's a question for you all. Turned on his headlights and proceeded driving. It was from Maine. My wife's from Maine. Same day, July 20th, 1963. That morning, there had been a wedding in Waterville, Maine. 5 years later to the day, also a Saturday, that bride's younger sister got married, also in Waterville. Her name is now Janine Standish. If that ain't the end, I don't know what is. Happy watching.